Yeah, that's a good question. I have to say that, I moved to the United States in 1985. So in that point, we had no credit card, no cell phone, no nothing. And you have to recognize in science field, there were no PubMed, no YouTube, no Gmail or internet, and so for me, coming here to the United States, the biggest thing was that I could go to lectures that I couldn't go otherwise, and I could listen what's going on in different field, and I remember once, like even we drove 1 hour to go to New Jersey because Bob Gallo is telling us what's going on in the HIV field, and so it was a different experience. And so, of course, I did not regret because I learned so much. I remember Mark Tushnev was the first when I went to a conference and he was talking. And I just was amazed how one person could know so many things. And I just wanted to be like them. And that's what, inspired me a lot. And I do not regret because, I usually, I make a decision and focus on how I can handle that. And not thinking about I should return or do things like that. That's always looking forward. I would suggest to everybody to go to another country, look at the nature, look at the culture, look at things. And then they think that, oh, it is so easy. Oh, in America, it is. No, it is not easy. Nowhere is easy. You have to learn, and so I would suggest the experience. That once upon a time, all of these tales, it was there that the guy went, and have some little food and went to experience the world. That's what, and then they learn more about, not about that country or that environment they went. They learn more about themselves. And that's what's important because you realize that you are able to do things which you didn't even thought that you were able to do. And that's what you can discover yourself if you leave your, comfort zone, the country, the language, the friends and everybody, and then you just experience. But I have to say, I had never been in homesick. I felt that the laboratory is my home, and where there was a laboratory there, that I was home. I think that when you are doing any kind of research, there is always questions. And I think that in me, I more questioned the thing, what I am doing, and try to poke holes on my thing that I thought that this messenger RNA could be therapeutic. And I have to say, when I told colleagues that I work with messenger RNA, they felt sorry for me. Oh, poor Kati, oh, I hate RNA. It always degrades and so on. But somehow when I was working with it, I felt that those who criticize, they don't see the result, and they don't appreciate, and I could see the opportunity there. Just I have to improve, because the problem was with this short period of time, small amount of protein was produced from the RNA, and it degraded, and it gone, and the protein is gone, and then. So that was why they questioned. But, my superiors and colleagues did not thought that it is a good idea. But what was important, and what I would emphasize all of the young ones, at least one person was rooting for me. And that one person had grant money, so they could sponsor, because, you can have great idea, but, you have to get salary and you have to have a little material to buy and to do the experiment. So you need one colleague. If the grant authorities, you cannot convince, but if at least one colleague who has money, that's what you have to do. And then to proceed. That's how I was survived. I think that everybody knows that in our genome, the our genes in a chromosome. That's where we have who we are, and we make all of our, the knowledge is there to make ourselves, with the different proteins, lipids, and different kind of components we are made of. And the knowledge is there, and this knowledge is permanent, very stable there. But from time to time, we need something to replace and to make a new protein, a new something, and then the information is coming from copied from this chromosome to a very transient little blueprint kind of thing, and comes out, and then it makes a protein. And what is interesting is that in our body we are modifying those, those knowledge. What is coming out, this blueprint, is a little bit special. What we are doing, what like a virus or other bacteria could, a pathogen would do. So this was the important that I tried to make for years, that to make this message which contains codes for a protein. I tried to make it, and it was inflammatory, making inflammation. And I want to use it, the mRNA, not for vaccine. I want to use therapeutic purposes. That I thought that, oh, you need a little bit of more of this protein here and there, and that how would it be, just we deliver there the mRNA and then you make the protein. And that inflammation was a serious problem. And so when we demonstrated that it's inflammatory, nobody knew that point. And it was like, for me, it was, for 7 years, I was just doing all of these experiments for nothing, because, it's not useful. And so that's together with Drew Weissman, who is immunologist. I was the RNA expert, and we discovered that why the RNA is inflammatory. And so the RNA, basically what I could say, the RNA and the DNA, everything is from 4 building blocks is made. And the order is defined at what we are made of. And then we change one of the building block, a very similar one, but less inflammatory nature. And that's what we get the Nobel Prize, that we discovered how we can make a messenger RNA, this blueprint, which would not cause inflammation when delivered to the body. I have to say that we already work with Pfizer on influenza vaccine to develop that from 2018. And we could see all of the animal data, even monkey data. We could see that how powerful if it is modified, and they made high level of antibody. So I kind of expected that it will be good. And when I learned that how well it works, I was happy, but somehow I expected that that's what it should do. And I have to say also in my life, in early on, I learned about how to handle stress and how to the expectations. So I was never craving recognition. So many people disappointed that, oh, they didn't say I did that. I never had that. Who cares? 100 years from now, nobody will remember us. Why we should fight for these little things? And so it was not a recognition. So it was all of a sudden, they recognized me, and I was like frozen there. I was in the spotlight and didn't know what to say, what to do, because we were not prepared for that. That's the other thing. I am sure that it is very helpful, because when I was working, and what is important, you have to understand some level that what the other person knowledge helps, how it helps, and what they can do, and has respect. You have to do that. And so when I met colleagues, physicians, and like David Langer was telling me that he can reach the brain vessel. Oh my God, I didn't know that. And you can deliver this. this knowledge is important. What the other person can do, what I can do, what is the problem we try to solve, and so that it is very helpful. And of course, when I met Drew Weissman, I mean, I learned immunology, in at the university when I studied. Oh, the immunology was over. That's a very different immunology, how we understand this. So I listened, I learned from him. I taught him that about RNA, and then when you work together, you have to respect the other person's knowledge and learn. And I think it is very helpful that if you are not just in your field, but look out what's going on in other place and how it impacts what you are doing. Yeah. I have to say, history shows that when people don't understand something, that they're afraid. I have to say, 100 years ago, even they protested against the X-ray. You know that today you would say, well, what is wrong with X-ray? It's fine. They can find where is the bone is broken or something. But the people imagine that, people incorporate to the glasses and they can see through my clothes, and then they see my body, and then always there are people make money because they started to sell 100 years ago X-ray resistant underwear because nobody could prove that it was going on. So there are always skeptic, and then as a Stoic, I thought that how did we get here? Because we did not explain to the public, that what is this vaccine? We had no time. We were busy in the lab, and those people who had no understanding, they went to the studio and they told about stupid things, but they could say so calmly. I immediately get excited, but they were so calm. Oh, and then unbelievable. And so they did not understand. Here is this coronavirus. It has 29 genes. It is a messenger RNA. The virus is a messenger RNA. It wrapped around with the viral proteins. And then those 29 different genes can kill you if that messenger RNA gets inside your cells. But we are selecting only one out of 29, and we deliver to your body, and it won't kill you, won't make you sick. It just train your immune system to recognize when the real virus is coming. That's what you have to see. And so this messenger RNA, it is also modified nucleosides present in the messenger RNA of the coronavirus. And people, when they say, we go back to the old method we make in eggs, they don't know that every time the virus is there, they had to adapt that the chick embryonic cells can be infected. It's not trivial. You just cannot put the virus there and the culture there. The virus needs get inside the cell, and you have to figure out which kind of cells you can culture it. And then how do you purify, how to kill the virus that you don't destroy immunologic properties. So this is not as simple as it sounds, and when you have an information like it was in 2020 January, I mean, information was there. The next day, 150 laboratories started to make vaccine because the information was enough. You can make the genes, you can synthesize it, you can make, and next day, 2 days later, you have the RNA. Just, it takes another 2, 3, 6 weeks to make more. And when you have a traditional way, now you have to wait. The package is coming with the virus, and you have to figure out how to culture it. I remember in 1985 when I came here, 86 HIV, 85 was still a big problem, and they didn't know which kind of cell they can culture the HIV virus, and they couldn't make a test for it. So they contaminated all of the blood bank and everything because they couldn't detect. They could not figure out how to make more of that virus to make an assay. So those people who do not understand science, they think that this is the traditional. That is not as traditional. You remember for the polio, for example, how difficult it was. They couldn't find a cell. And finally, what they found, these monkey cells had already a virus in it. And then everybody get infected with that virus also when they get the vaccine. So it's not that simple and very challenging. And it takes much more time and to develop something. And your reaction time will be much, much longer. Yeah, I have to say, I never wanted to write a book, but when people wanted to write my life, I said, "Oh my God, who cares about the boring life of a scientist?" As I at the beginning, I am saying, I am just pipetting there, for maybe 40 years, just pipette, and this is not something exciting. But eventually, I want to write the book because, first inspire all of the young one, that you don't have to be born in a professor's family, because my father and my mother had only elementary school education. We didn't had books at home, not even maybe cookbooks, no books. So but we could go to the library, and so you can come to the humble beginning. You can have that humble beginning. You can study and determine what most I wanted to have these kids that to believe in themselves, and then get this stoic philosophy that don't care about what you cannot change, because you're just wasting your time. Focus on what you can do, always what you can do. And what you can do, what I can do right now, is educate the public, inspire the next generation of scientists, and help them to focus on the exciting scientific topics, because this way they can do the same thing and much happier. I was so happy. My husband always said, I am going just to have fun. And people thought that, oh, because I was rejecting my papers and my grants, that I should be sad. But I was, advancing, and I had fun. And that's what I try to help the fellow scientists, to see the beauty of investigator, scientific, researcher, because I wrote in the book, we are not searcher, because we repeat so many times the experiment. So we are researcher. And
Researcher.
and yes, and also the public, that they, this life, the cells, there are so much complexity, and even we don't understand. There's so many things is there to discover, and but the scientists are just like them, one of them, working, try to do their best. And they because right now they think that the scientist is very remotely, thinking something, and it was so much against science right now, anti-science. That's and and we are responsible as a scientist, because I like to talk fellow scientists, to discuss what to talk to a public. I have to think about the word I should use. Is challenging, but I have to say, in November also, I will go to a library in Hungary. Now I was here in the local library, just so people could see that, oh, she's in the grocery, she's doing grocery shopping, she's the same person. And no, she's talking about this, to know that we are one of them and we are working very hard. But we have to have explain to them what we are doing, so they would trust scientists. So you could see right now more than 150 clinical trial ongoing with messenger RNA. Most of them, maybe half of them, is vaccines, mostly viruses like flu, Zika, monkeypox, and others. You can see also in bacteria, against bacteria which cause Lyme disease or tuberculosis. Or I was just reading now that the clinical trial is ongoing for acne, which cause for this. So this is already human trials. Of course, more attention as cancer. And for cancer, it could be vaccine, it could be individualized vaccine for only for that person who get that tumor is effective. Or it could be a shared tumor antigen, so that could be used off the shelf and can person can be treated. There are also messenger RNA coding for antibodies, because the antibody is very expensive. But if you deliver the messenger RNA, your body can make the antibodies. So they are also for cancer, they are using. They use for CAR T cells, to generate against cancer. And also CAR T cells in human trial where they fight autoimmunity. Myasthenia gravis is already phase 3 trial, very advanced. They use for lupus. And so these are examples. And genetic disease, which originally I wanted, or these are more like a genetic disease when somebody by mutation, they cannot make a certain protein. And it is very fast. You heard about the KGJ kids who was born and, the ammonia was accumulated here in the children's hospital. They immediately identify where is the mutation. And they generated messenger RNA coding for the Cas9 to correct that error. And the kid is at home and no ammonia is accumulating anymore. So it is so fast you can respond with this and adopt. And I mostly, my daughter is a rower, and always I had to puncture all of these blisters, and I was always thinking that, I wanted to deliver messenger RNA, which is already present in the body, but not enough, not the right place, not enough. And then I was thinking, there will be a little collagen 7 messenger RNA if I could deliver there when I puncture the blister. I could deliver there, cells would pick up and would heal much faster. So that was my goal always, to deliver messenger RNA. And but I can see that so many other fields, they are advancing, and also actually on this therapeutic. So the science you cannot stop. No politician can stop. It is shifting. If you look for messenger RNA therapy human trial, most likely that majority of the trial is ongoing in China. They are doing in Iran. I mean, I corresponded with the researcher, their students, and they are using RNA because it is very, very simple. You have to just transcribe, and everything is available, and very cheap. You can make very cheaply, and because you deliver the messenger RNA to the body, and the medicine is the protein, but you deliver the precursor of it, yeah? But if you deliver the protein, it is expensive because you have to purify, you need big fermenter, so it's very expensive. And eventually, maybe during purification, it refolding and it will be toxic. But, your body knows how to fold the protein to make it functional. And so it is very affordable. And you could see that all over the world, they are making mRNA. And companies in Africa and others, they donated or set up facilities there. So the technology is very simple. If I would have my reagent, I could do right now here on my office, on my desk. For me is the fellow, I am responsible towards fellow scientists, encourage them and help them to have fun and not to deal with many of the things which makes our life difficult, and the young generation, because less and less people are interested in science, and they want to be an influencer, And I feel, when I ask students, like in Canada, there were like 300 high school students, and whether they can name a hockey player, everybody could name hockey. But when I ask whether a Canadian scientist, whether you can name one, nobody's anything, nobody. And who is responsible for it? Who? I cannot, as a Stoic, I cannot blame others why they are not doing what I should do, what I can do. And that's, and so my book is, here it is actually, here is the US edition, but it is out in, 14, 15 different languages. Right now, just was published in Serbia, but it's coming out in Brazil in Portuguese and Polish and this is Chinese and Korean and other European languages, many. It is important, as I learned from scientists from other corner of the world, to show that, hey, failure is not end of it, because sometimes suicide rate is very high in academia when they are not succeeding in something. And, because, I left Hungary, I was terminated in my position, we ran out of money. I was demoted here. I was kicked out, Temple University, eventually University of Pennsylvania. I was forced to retire. And so I had a lot of difficulties there, but the example is just, okay, figure out, okay, if they don't want you there, can you do something else and go somewhere and take your knowledge in another country or to the industry, go to the industry. I mean, for me, it was refreshing because here in academia, how many papers, if I have not published even 100 papers because I did all of the experiment. I was 58 years old. I was still pouring the gel, running the sample. I had no technician, no help. And so that's what they counted, how many publication, how many reference, and we go to the industry now that we have to have something that helps somebody. So it was refreshing. And so I try to tell with my own example that you be useful, helpful, and figure out. Just keep moving. I had in Hungary, in affordable, high quality childcare, and that's why I didn't have to give up my position when I had my daughter. And so that's what I also try to encourage the women scientists. You don't have to make a decision to have a family or to follow the science and your career because, I have my daughter and she was, 4 months old and she was in the childcare and, she came out okay. She get graduated PAN and then get 2 master degree and 2 Olympic gold medal. They need help and they need, affordable, high quality childcare because, otherwise, they have to stay home if they decide that they want to have a child. And yeah, so that's also an important issue that we have to emphasize. And, it is very expensive, the childcare everywhere in this world. But if they would be government subsidized, then it would be affordable. And it would, not just scientists, but many other professions, the women would proceed and they can take a leadership job because, no director, if it is a male, they asking, oh, how your children are doing if you are here, but for a woman, they will ask